Hello, my name is Denis Shevchenko, and today I will be teaching a lesson on the division operator in relational algebra. So the division operator in relational algebra. There are a few things that we need to remember about this operator. First and foremost, I don't think it's even worth writing down, but much like in normal algebra, it is an operator on two things, so A divided by B. Except in relational algebra, these are sets, so we're dividing two sets. Now the division operator, A divides B, can be applied, A divided by B can be applied if and only if attributes of B are a proper subset of attributes of A, which means that if something is in B, it must be in A also. However, proper subset means that they cannot be the same thing. So B cannot be equal to A. Another thing that we need to remember is the returned relation has all attributes in A minus all attributes in B. What that basically means is we look at an attribute in A and we say, is this attribute that is in A also an attribute in B? If the answer is yes, we don't care about it. We do not want it because of this minus here. If the answer is no, then A minus B, we do not subtract that attribute in B, so that's the attribute we keep. We only keep the attributes that are in A and not in B. And the final thing is returned relation has tuples of A that are associated with every tuple in B. And every here is underlined because that is basically the most important thing of the division operator. That's why we use it, right? It is generally very good for when we're making a query for, say, for every or for all. So let's do a little example here to kind of show what all of this means in practice. So suppose we have a TV show, and it doesn't matter what TV show it is. Say there are 6 episodes in the TV show, but we don't care about episodes 5 and 6. We only care about season 1, which has episode 1 and 2, and season 2, which has episodes 3 and 4. Now here we have a table, actors in episodes, denoted by X. Here are the names of the actors and the episodes that they were in. And here's a little legend for this table. Basically, A for Alan, B for Beth, C for Charlie, pretty much just for simplicity, to kind of make it a real life example. Now say we want all actors who were in every single episode of season 1. So what we do is X, this table is denoted by X, actors in episodes. Season 1 is denoted by Y. So X divided by Y equals, let's call this T. Now in table T, what we want is names. And the reason we only want names and not the episode numbers is because of this. Returned relation has all attributes in A minus all attributes in B. So all attributes in A, or in X in this case, are name and episode number. All attributes in B are episode number. So we're doing name and episode number minus episode number, which means we only want the name. Now the name that we get in here is Alan. And the reason we get this name is because we look at season 1. Well, season 1 has episodes 1 and 2. Now, who has been in every single episode of season 1? Meaning 1 and 2. So Alan has been in 1 and 2. So Alan definitely makes it here. Alan. Now let's look further. Beth and Charlie have been in episode 2, but they were not in episode 1, meaning that we don't put them in this table. Because we only want the things that are associated with every single thing in this table. Charlie and Beth are only associated with 2, but not 1, so we don't care about them. Well, we do care about them, we just don't put them in this table. Now say we want the people, all the actors who were in every single episode of season 2, denoted by Z. So what we do here is X divided by Z will yield, let's call this T prime. In our table, T prime names, once again, we want all the attributes of X minus all the attributes of Z. Attributes of X are name and episode number. Attributes of Z are episode number. So it's this minus this. We only care about the name. Now, we're looking at season 2. So episodes 3 and 4. Well, let's see here. Who has been in episodes 3 and 4? Must be in both of them, right? So Alan, 3 and 4. So Alan makes it on the list. Let's see here. Beth was also in 3 and 4. So she also makes it on this list. And now let's look at Charlie. Charlie has been in episode 2 and episode 4. And also episode 5, but we don't care about that. So he has been in one episode of season 2, but he hasn't been in all of them. Which means that we don't put Charlie in this table. We only want the people who were in every single episode of this season. And that's pretty much all everything that we need the division operator in relational algebra for. It is a very handy tool for when we're querying for something that has been a part of all of the members of another thing. Thank you.